Okay, so let's prove the alternate interior angles theorem. So one thing you need to know about proofs is that if you're going to prove a theorem, like the alternate interior angles theorem, then you can't use that theorem. So in this picture, you don't know that angle 1 and 2 are alternate interior angles and that they're congruent because the lines are parallel. You don't, okay? That's what you're trying to find out. So we are given that lines M and N are parallel, again, by the arrows. And we want to prove that angle 1 and angle 2 are congruent. Now, there's this third angle here. I assume we're going to use that somewhere throughout the proof. So let's remember that we have our transversal here. And again, this is our interior space. So all of those angles are in the interior. So any proof always starts with a given. So let's start with M parallel to N. That's going to be given to me. Okay, so now let's talk about the other angle pair relationships up here. So let's go with 1 and 3. 1 and 3 are both to the right of the transversal and they're inside the parallel lines. They are supplementary. They're going to add up to 180. Measure of angle 1 plus measure of angle 3 equals 180. And it's because they are same side interior angles. Let me put numbers here too so we stay same side interior angles. And that's the postulate. If you just put same side interior angles, that's fine. Now, what about angle 2 and angle 3, right? They're right next to each other. They're adjacent to each other. They form this line N. They are a linear pair. They will also be supplementary. Angle 2 and angle 3 will equal 180. They're also supplementary because they are a linear pair. And we called that the linear pair theorem, but again, linear pair. So now what do you notice about these two equations? I notice that both equations have the 180. So we are going to use what's called the transitive property, and we're going to take out the 180 and replace it with the other angle sum so that we have the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. So we took these out and put these two angle sums together. That is the transitive property because both sums equal the same thing, so both sums equal each other. Transitive property. So now in step 5, I see the same thing on both sides. I see the measure of angle 3 here and angle 3 here. We can subtract that away and leaves us with the measure of angle 1 equals the measure of angle 2. That is just the subtraction property of equality. Subtraction property. And if two angles have the same measure, then by definition, they are congruent. Angle 1 is congruent to angle 2. And again, it's the definition of congruent angles. We talked about that way back in chapter 1, in topic 1. If two angles have the same measure, then they're congruent. And this is a way to prove the alternate interior angles theorem. Notice I did not use the alternate interior angles theorem in the proof. I used same side interior angles postulate. Great. Okay, next. Oh yeah, let's take a look at this one. Woohoo! All right. So now we're going to look at this proof. So we need to use this diagram with all this given, and we need to prove this. All right. So lots going on here. So let's take a look here. So let's start with all of our given. I always like to start with all the given. Yes. So here we go. So we have that AC is parallel to DF. We have that BE is perpendicular to DF. And we have that angle AEB is congruent to angle CEB. Look at all that fun stuff. Right? And that's all given to us. And it's all marked, right? AC parallel to DF. BE is perpendicular to DF. And angle AEB right here is congruent to angle BEC or CEB. We want to prove that angle BAE. Where is BAE? We want to prove that this angle BAE right here, I'll do two arcs in blue, if I can get the blue. Yep. That this angle here is congruent to BCE, which is this angle here. All right, so let's see what we can do. Well, first, let's use the idea of perpendicular. Okay, again, you can do this. You can attack this proof in many ways. But if we have perpendicular lines, then I know that I have some right angles. I know that this angle here, BEF, and this angle here, BED, are right angles. So I'm going to write that down. I'm going to use green. So this is a right angle, and so is that. So angles BED and angle BEF are right angles. And that is simply by the definition of perpendicular lines. That's me using this guy. And now, since I know that they are right angles, I have complementary angles up here. I have two angles. I have two angles that are added together to make these right angles. So for angle BED, I know that angle DEA plus angle AEB is equal to angle, oh, I'm sorry, is equal to 90. I also know that angle FEC plus, so FEC is on the left here, plus CEB is 90. And really, I should have measures in front of these if I'm being totally honest. And this is because they are complementary angles, definition of complementary angles. And again, it's because they make these right angles here, as we know here. So now we got to throw an old idea out at you, okay? So we have AEB and CEB here, but we also have them right here. So DEA and FEC are both complementary to those two angles, and those two angles are congruent. So if AEB is 30, then so is CEB. So that means that AEB is 30, CEB is 30. That means that these two angles would be 60 and 60. That means that these two angles would be congruent to each other. There is a theorem called the congruent complements theorem. You probably don't remember this. We learned it back in topic 1. But because angle DEA and angle FEC are complementary to congruent angles, they are congruent to each other. So angle DEA is congruent to angle FEC. And this is called the congruent complements theorem. Okay, so now if you look at this picture, okay, so where is DEA and FEC? So DEA is here and FEC is here. Well, now if we take a look at the parallel lines, because we really haven't used this yet, right? Well, if you look at the parallel lines, I think that angle DEA is alternate interior with angle EAB, this angle right here, or BAE, this angle, right? I'm going to use 3 and 3. They're congruent. Okay, FEC, this angle here, is congruent to BCE, this angle here, because they're alternate interior angles. So I think that I can use alternate interior angles to prove what I want to prove. So here's what I'm going to do in step 5. I'm going to talk about these two angles being congruent to their alternate interior angles. So angle DEA is congruent to angle BAE. And angle FEC is congruent to angle BCE. So those are the alternate interior angles theorem, which says that if lines are parallel, alternate interior angles are congruent. And now what I can do is, since I know that DEA and FEC are congruent, I can use the transitive property to replace BAE for DEA and BCE for FEC, and I get what I want to prove. So I'm going to do step 6 right here. So I'll use blue to do that to show you. So step 6, I'm going to take out DEA here and put in BAE there. I'm going to take out FEC here and put in BCE there because they are all congruent to each other. And we get what we want to prove. Angle BAE is congruent to angle BCE, and that is by the transitive property. And there we go. That's a tough proof for sure. To be honest with you, the first time I did this proof, I did not use this theorem right here, right? I did not recognize it, but it makes it easier. It makes it simpler, I should say, not easy. This is not an easy proof by any means. Okay, last but not least. Find angle measures. The white trim shown for the wall of a barn should be constructed so that AC is parallel to EG, JA is parallel to HB, and JC is parallel to KG. What should measures of angle 1 and 3 be? So notice here that they do give you one angle measure, and that angle measure is angle A, right? They give that to you, 68 degrees. So we need to use that angle measure to find 1 and 2. And again, we have these parallel lines. AC, where's AC over here? AC parallel to EG. JA, where's JA? JA parallel to HB. And JC, notice the arrows, I'm using 3 now, is parallel to KG. I could have moved KG over here, but it's okay. So I have all these parallel lines. So let's talk about what kind of angles might be congruent, right? Okay. So if I look here, if JA and HB are parallel, then I know that angle 1 is going to be same side interior with the 68-degree angle, right? Because here I have parallel line, and here's my transversal. So to find the measure of angle 1, I would just simply add it to 68, and that would be 180. I'm going to subtract 68 on both sides, and the measure of angle 1, the measure of angle 1 would be 112 degrees. Okay, there we go. All right. Now to find angle 3, I'm going to go through angle 2. Right? So to find angle 2, let me change it to orange. So I'm going to use segments AC and EG being parallel. So here's AC, here's EG. So this is my transversal I'll use. 68 and 2, they are corresponding angles. They're both facing down. So they're corresponding. So we have angle 2 is corresponding with the 68-degree angle. So that means the measure of angle 2 equals, the measure of angle 2 equals 68 degrees. Okay, so that helps me, right? So that's 68. And now to find angle 3, I'm going to use angle 2. Because if I take a look at segments JA and HB again, which were in blue, right? I'll make them in green now. Now I can use EG as my transversal. And now angle 2 and angle 3 also both open down. They're corresponding as well. Angle 3 corresponds with angle 2. So they're going to be congruent. And if angle 2 is 68 degrees, then angle 3 is 68 degrees. Sorry about that, 3. And there's your two angle measures. Fun times, right? Good problems. Okay. So thanks for watching, and we'll see you next time.